What is happening?
So do I. I've been able to the right side of my mouth for 6 years.
Oh yeah,
But as soon as I have health insurance and time, I take pretty good care of it. You don't have health insurance? Yeah, I do. But like I did before this, in between jobs, and now I don't have time to go. Right? So I gotta find a dentist and do all that stuff. Because you know how healthcare works in this country, right? You can't just go to any dentist. You have to go to the one that's approved by your plan and all this other nonsense, right? Yeah.
I hate dentists.
What if I bite the
I'm
dentist?
so afraid.
So
I will get that taken care of eventually, and then I'll give you light dentist on both sides of my mouth. Right?
Yeah, but and are you in this chat?
Alright, let's rock and roll. I had graph paper ready.
Not much graph paper.
That's my best friend.
Crossed my back.
Alright, so today, we're not talking about triangles because we're not geometry.
Why?
Which is sad. Because
Next year, Mr. Matt.
we're talking about parabolas, parabolas, right?
Parabolas.
So, let's talk about it. So, what have we learned over the past few days? Well, we know that parabolas are quadratics, right? They're squares. We call them quadratics because quad means, what's that? 4, right? So x squared is what we have. This is the basic parabola, right? That means we're going to get a parabola that's centered at 0, 0, going up because it's positive, right? And goes at the same rate on both sides. It doesn't look lopsided like I just did, right? But we've also learned there are other ways to write this parabola. Right, this guy. Now this is vertex form because it gives us the vertex. Our vertex is going to be h comma k. Notice that if h and k are positive, k stays positive, right, when we plug it in, right? So whatever k is what it is. If you have a -2 there, then k is -2. If you have a +2 there, then k was +2. H, on the other hand, because of the formula, changes signs. That's what negative means, right? A negative times a negative changes the sign to positive. A negative times a positive changes the sign to negative, right? So if h is 2, it'll show up as -2 here, right? So it's kind of tricky. If h is -2, negative times a negative is a positive, so it'll show it as a +2 there. So we have to be careful. That'll be the vertex. Remember, the vertex is where it intersects the two curves, right, where they come together. That's the vertex. And of course, this has a vertex at 0, 0, because with h at 0 and k 0, x minus 0 is x squared, plus 0 is just x squared. Okay? We've also learned about this, Parker pointed this out, that we can do something like this.
Frickin' Parker.
Right? These two are going to multiply to get an x squared and a bunch of other stuff, right? But at the end of the day, it's an x squared, so it's going to be a parabola. What we put here is going to be our x-intercepts. So if I were to put a 2 there and a 3 there, what number would I have to plug in here to get 0? And -2, right? -2 plus 2 is 0. So I get 0 when I plug in -2. So I have 0 here. What's 0 times whatever this is? 0, right? So when I plug in -2, I get 0. So I have a coordinate, -2 comma 0, right? And that's here. What do I have to get 0 over here, though? Because I have two options, 2 ways to get 0, right? What do I plug in here? No, if I plug in 0, I get 3, right?
-3.
-3. -3 plus 3 is 0. 0 times who cares is 0. So -3, 0 works, right? So our parabola goes through both of those points. So it's really speedy, right? And I know it's going up because the number in front of here is positive, right? There's no negative. Where's the vertex? I don't know yet. But it's somewhere down below here, right? That's a sketch of it. Does that make sense? So if we want the parabola to go through 2 points that are on the x-axis, it's really easy to set up. We pick the 2 points by doing this. Cool. We learned the other day that if we have something like this, another way to write this is to distribute, right? If I had 2 times the quantity of x minus 3, you distribute the 2, right? If I had x times the quantity of x minus 3, you distribute the x. So if I have both, you just distribute both. It's really not anything crazy. A lot of math teachers teach FOIL and all this crap, first hour, inter, last, but it really only works when you have 2 terms each, here and here. I'm just teaching you that, guys, this is just distribution. It's not a new thing. We don't need to spend 2 weeks learning how to FOIL. You distribute. Do we get that? Great. I don't know why math teachers make that hard. Guys, what's 2 times x?
2x.
What's 2 times -3?
-3. No, sorry. It's -6.
Pink, so you know where I got it from, right? Now I get to strip the x, right? What's x times x?
X squared.
It's positive, so I do a plus sign. Right? And then what's x times -3? Negative 3x, right? Okay. So again, the 2 got distributed, the x got distributed. No big deal. Again, if I just had a 2 there, you distribute the 2, no questions x. 2x minus 6, right? If I had the x there, you'd say x squared minus 3x. So if you have both, you do both. What if I had a third thing here? Then you just distribute that. I don't know why we spend like an entire month doing this in regular algebra classes. We're not going to do that here. Is that okay?
Mm-hmm.
Okay, good. I think you all are good enough to handle that. If you don't see it yet, that's okay, because it is new. But once you see it, I think it makes sense. So now I can combine all these. How many x squareds do I have? 1, right? So I just write x squared. I'm going to write that first because it's the highest power. I'm just kind of put it in order. You don't have to, but I like doing it. How many x's do I have? 2x minus 3x, right?
-1x.
So -1x, right? Negative x. And then I've got -6. No other numbers, right? So it's just -6. So that simplifies to this. So it turns out this is the same thing as that. Okay? We call this standard form. Because that's the standard way you'll see it. Order of powers. Squareds, regulars, numbers. Does that make sense? If we do cubic functions, we saw what those look like. They look like this, right? X cubed. Then we'd have cubic, square, right? And we write it in that order. That's why it's called standard. We're used to seeing something like this. If I cover that up and I have this, what do I have? It's not a parabola anymore. What is it now? What will that look like when we graph it? A line, right? A line. Slope of -1, right? Y-intercept of -6. This is what makes it go. Okay? So, we learned how to get 2 points on the x-axis, right? We write something like this. It's very simple. We learned how to get the vertex set. What if we want both, right? It's going to have something to do with this and getting this guy right here into that form. So we're going to play around with that today. Let's look at Desmond. You guys have been a great audience.
Thank you.
Thank you, sorry.
Did I miss anything important yesterday?
Yes, we did.
Oh.
Make sure you get into Desmos. We did this. Ooh. Look what Lexi did. Yeah. So where we left off was this.
Yeah, we did that too.
All right, let me try to light these a little bit better. I'm afraid of the dark. Let's go. All right, so the objective for number 7 was that we wanted parabolas that have these vertices, right, where they come together at, right? But we wanted them all to go to the same points. So we knew, in order to make them go to those 2 points, right, those 2 x-intercepts where it hits the x-axis, we need -4 and 4, meaning that when we plug in -4, we should get 0, right?
Yeah.
When we plug in 4, we should get 0. That's what those coordinates represent, right? So when I plug in -4 to this, well, I get -4 plus 4, which is 0. 0 times all that stuff, it's going to be 0, right? 4, if I plug it in. If I plug it in here, I get 4 minus 4, which is 0. 0 times all that rest of the stuff is still 0, right? So that works. How did we know we needed -5 for the red one? Here's what we did yesterday. We said, look, I know it'll go through that and that. Lexi, sorry. But without that 5 there, it goes through here, but it doesn't go through there. Why is that? Well, if we plug in 0, we're going to get this point, right? That point is -16. Check it out. When I plug in 0, what's 0 plus 4? 4! Plug it in over here. 0 minus 4. -4. What's 4 times -4? -16. We're multiplying. 4 times -4. -16. So we plug in 0, I get -16. What do I want when I plug in 0? 80. So normally, without touching it, right, I get -16. Now I can't add on to it, because if I do that, that's going to change things. Watch, I'll add on a 1. And it throws everything out of whack. See how it doesn't go through those points anymore? And it's because when I plug in 4 now, I don't get 0, right? I plug in 4, yeah, I get 0 there. 0 times anything is 0, great, but then I have 1.
There you go.
Right? You see how that screws it up? Adding and subtracting screws up that. So I'm only allowed to multiply. That way when I multiply, it still becomes 0, right? Everything multiplies together, gets 0. But I need to change what I'm going to multiply by out front. So I'll end up going through there. So remember, when I plug in 4 now, I get, or when I plug in 0 now, I get negative 16, right? Somewhere down here. I want to get 80. So the question is, what do I multiply by? Because I'm not allowed to add or subtract. That screws everything up. What do I multiply negative 16 by to get 80? Mitchell, what do I multiply negative 16 by to get 80? What do I multiply by?
Negative 5.
Negative 5. It's got to be negative, right? Because I want to be positive, right? Negative times negative is positive. Negative 5 times 16 gets me 80. Before I got 16 without the negative 5 there. So negative 16 times negative 5 gets me 80. And that's how we figured out where to put them. Has everybody done number 7? I want you to try it now. If you're stuck, I'll come around and tell me.
Wait, 7?
Challenge 7.
Yeah.
Not page 7, the challenge
This and
7.
that.
Yeah. All right, 1 second. Yes. I'll get you the class code. Jordan should have been working on this, so you can work with her on her thing. This is going to be how our quiz works on Friday. We're going to have a quiz that's like this. That's the plan. Try challenge number 7 if you haven't done that yet. I'll come around and help you. Mitchell, you operating on your phone?
Okay, we're stuck in green.
Green? Okay, so right now with your equation, it's not even going through those two. So you want to rearrange it to make it go through those two. So don't do that, right? Do it like you did the other ones, right? It's going to be x plus 4 quantity, right? X minus 4 quantity, right? You want to even copy and paste, but yeah, that works. Cool.
This man, you're going to be here.
Yeah. Game club today. All right, so get rid of the 2. Or I know you don't have to do that. So right now, it goes through where? Let's check what that point is. Mitchell, are you with me here? Right now, we're going to check what that point goes through. So I'm going to go over here real quick. That's negative 16. Okay? And that makes sense, because when we plug in 0, right? Plug in 0, 0 plus 4. 0 minus 4.
Oh, yeah.
So we have 4 and negative 4 when we plug in 0. We multiply those together, we get. So when we plug in 0, we get negative 16. That makes sense, right? What we want is when we plug in 0 for that point. What point is that? Positive 16. So if it's already negative 16, what do we have to multiply that by to make positive 16? So if we put a negative 1 out front, go through, right? Makes sense? And that's how you get the rest of these. I want you to make sure you understand how this works. So now you copy them down from the left to the most part, right? But that's the idea. Okay? How are we doing? Okay, I need 2 people to sit on 3. All right, group 3 over there. Logan. You're not with them. You're not in their group. You got to work in a group of 1 or a group of 2. Preston needs somebody.
Well, what about the stuff that I already did?
Which you did with them?
Not with Ethan yesterday.
With Ethan yesterday? Who's your partner yesterday?
He-
Oh, because Adam wasn't here.
And before, I was partnered like by myself, remember? When we were working on that stuff, it all erased.
Gotcha. So start from this point. You guys can work together. That's all good. How are we feeling about challenge 7?
I thought my challenge on figuring it out. 48. Then I'm lost.
All right. So what we want is to go through negative 4 and positive 4. So you're going to have the same start.
That's what you're thinking.
Let's go there. Okay. Start with that.
Go next one. Challenge. Next challenge. Already got this first round.
But you gotta give colors.
But I already got the first one.
Oh, yeah.
Now we need the
Notice
second
it's
line.
not the vertex, the vertex is then the
That way.
This should be
We need to get that.
It's going to be a random point of time. So we need these two guys before, and then we want something that
Turn
where the
it so I can
vertex
see.
instead of foot goes through there.
Silver one practice.
See if you can figure out why that works. Okay? It's going to be tough. First of all, it's going to be a downward parabola, right? You need a negative a value, right?
I figured out Mr. Math.
Rad. Do you see why that works, Dave?
Not really.
Okay, well, I'm going to talk about that again in a second.
Alright.
How are things going? Are you in on the challenge?
So now I'm not just. Yeah.
What I would do, have her help you because she's been here all the day and she's been kicking butt. Okay?
I got it through all
Right,
three.
but you know why
I got it all through all
You
the
got it.
lines.
Not really.
Okay, give them the basic understanding and then I'll go up here and teach about why.
Does this count?
I don't know what that is.
For this one? Oh, you completed 7? No, it does not.
Yeah, I completed 7.
Yeah,
I can't figure it out. How do you get it? If there's 3 points. And
All right, I'm going to talk about why number 7 works again. So if you are confused right now,
I already got
you should watch.
Yes.
Yeah, number 7.
All right, so let's work on 7 together. Now would be a good time to watch. So here's my logic. I know that all of these parabolas need to go through 4 and negative 4. So here's the idea. I know that x plus 4 and the quantity of x minus 4 are essential, right? Because what do these points represent? It means when I plug in 4 for x, I get 0 for y. Does that make sense?
Yeah.
Right? That's what a coordinate is. 4 comma 0 means when you plug in 4 for x, you should get 0 for y. So whatever my equation is to get through those two has to do that. When I plug in 4 for x, I get 0 for y. I don't care if you're not paying attention right now so much, if you've got it, but you need to shut up so other people can hear. So I need when I plug in 4 for x, I get 0 for y. Check my equation. If I plug in 4, I get 8 here. If I plug in 4 here, what's 4 minus 4?
0.
So I get 8 times 0. 8 times 0 is 0. So 4 does get me 0, right? Negative 4 also gets me 0 because when I plug in negative 4 to this one, right, I get 0 and negative 8. 0 times negative 8 is 0, right? So the way we set this up is if I want 4 to be my x-intercept, right, for the x-axis, then I need an x minus 4 over here, right? So when I plug in 4, I get a 0, and 0 times anything is 0, right? For the other one, I want negative 4, so I'm going to have a positive 4 here. That way when I plug in negative 4, I get 0 here, and who cares over here, because 0 times anything is 0. So that will get it to go through those points. However, you'll notice it does not go through the correct y-intercept, the correct vertex, right, where the two come together, right? So what do we get? When we plug in 0, it looks like we get this coordinate, right? What is that coordinate? 0, negative 16. So we plug in 0, we get negative 16. Let's check that. What's your question?
I found that put like a negative in front of it.
Yes, great. I don't care about the answer. What I want to do is talk about why it is. So I get to that, and we should have the same answer. That's good. So when we plug in 0, we get negative 16. That's how it's set up normally. If we check, we plug in 0. What's 0 plus 4? 4. What's 0 minus 4? Negative 4. What's 4 times negative 4? Negative 16. Do you see how 0 gets negative 16? We should not be surprised by this result, right? We want it to be 0, 80, right? That's where we want it to go through. So meaning that when we plug in 0 to whatever this is, we want 80 to pop out. Now here's the problem. If we change this stuff, it'll no longer go through those points, right? So we can't touch this. If we add on to the end, like, oh man, it's at negative 16 right now, we'll just add on 96, right? Well, it goes through there, but look, it moved everything way too far up. It doesn't go through these guys anymore. And the reason for that is because now when I plug in 4, yeah, I get 0 times whatever, and I get 0. But then I add 96, and I get 96 now. So you see how adding and subtracting screws it up? Jordan, are you with me on that? Adding and subtracting screws it up? So I can't add or subtract. I want to keep it like this and then multiply it by something, because then I multiply by something, that'll change where it ends up here. But it'll still make 0 for this, because when I plug those in, 0 times anything gets me 0, right? So if I have a 10 in front, it won't change anything, because I'll get 0 here when I plug in negative 4, right? When I plug in negative 4, I'll get 0 here. And 0 times who cares is 0, right? It still maintains that. Do you understand that concept? It's a lot of words. Do you understand how if I plug in negative 4 here, right? I'll get 0. I'll get negative 8 here. 0 times negative 8 is 0. Times 10 is still 0. So multiplication doesn't screw these guys up. So I can multiply by whatever I want in front and still hold that true, okay? I can have nothing in front, or I can have 6 in front, I can have whatever I want. We'll still go through these two. Because these points represent when I have 4, and I plug it in, I should get 0. That doesn't change that by having a multiplication. Yes. Is everybody cool with that idea?
Yes.
Jordan, are you sorted with that? Okay, I'll take sorted. So the question is, right now, I get 16, right? Negative 16 when I plug in 0. I want, when I plug in 0, for it to be 80. So when I plug in 0, this becomes negative 16. What do I multiply negative 16 by so that it becomes 80 instead?
Negative 5.
Negative 5. So if I multiply by negative 5 in front, that negative 16 becomes positive 8. Does that make sense?
Yeah, but I would never like, be able to figure that out. Like, I can't.
16 times what is 80? So you'd have to do 80 divided by 16, right? And you'd get 5. I would reason this way. 5 times 10 is 50. 5 times 6 is 30. Add them together, you get 80. Okay. Will the numbers be that crazy? No? But right now, they are. Okay. I'll help you with that. Logan.
Oh, what if I just put like the negative in front and like no 5, but then I just add 64 at the end because 16 plus 64 is...
Let's check that out. So y equals, you had this, y equals negative quantity of x plus 4.
Yeah.
Quantity of x minus 4. And then what did you do?
And then I did plus 64 because 64 plus 16 is 80.
Does it go through those 2 points?
Yeah.
Yes.
The blue does not, right?
No, I was talking about... Oh, wait. Never mind.
Yeah, you see what I'm saying?
Wait, yeah, we did that wrong.
Yeah, so it wouldn't end up going through it. It does screw it
I
up,
was looking
right?
at it wrong.
So the reason that doesn't work is because, remember, you want when you plug in 4 to get 0, right? Same thing with negative 4. If I plug in 4, yeah, I get a 0 here, and I get 8 there, and I multiply it, I get 0, right? 0 times a negative is still 0. But then I add 64 in. So when I plug in 4, I get 64 as the answer. Which is why when I plug in 4, I get 64. Right.
I'm an 8.
Great. I will get there. Are you okay?
No.
Okay, but I gotta do this right now.
Okay.
Okay. All right, so that won't work for that. We're not allowed to add or subtract because that fundamentally changes what we were working with, right? So all of these are going to be the same thing. They're all going to be y equals this. So I'm going to just copy and paste that. Okay. Ugh, all those colors blended together. Now, we're going to change these to make them go through their respective stuff. So we want, instead of negative 16 when we plug in 0, we want it to be positive 16. That's for the green one, so I'm going to go here. Jordan, right now when I plug in 0, I get negative 16. I want it to be positive 16. So what do I need to multiply that by? Let me say it again. You do. Right now when I plug in 0, I get 0 plus 4, which is 4. And I get 0 minus 4, which is negative 4. When I multiply those, I get negative 16. That's why it goes through here. I want it to go through here, meaning that when I plug in 0, instead of being negative 16, I want it to be positive 16. So right now, it's negative 16. That's what this is. What do I multiply that by to make positive 16? The question we're asking is negative 16 times what gets me positive 16? Make sense? Before we had negative 16 and we wanted to make it go through 80, that was a harder question. You times it by -5, right? Let's look at the blue. Right now it's going through -16, right? 0, -16. I want it to go through 48. So first off, what kind of number do I need to multiply -16 by to make 48? What kind of number do I multiply by? A negative, right? And that makes sense, because I want my parabola opening downward almost, right? That put it through here. It's overlapping with the green. Okay? I do the same. But I don't want it to be regular 16. I want it to be 48. What do I multiply regular 16 by? Because that's what I have now after the negative, right? What do I multiply 16 by to get 48? What do I multiply 16 by to get 48? Take a guess. 16 times 2 is 32, right?
I have this one.
What is it?
I put -3.
That's right. 83, right? Boom, and there it is.
Science.
Right now, our regular one for orange goes through -16, right? Because that's what you get when you plug in 0. I want it to go through -32. So what do I need to multiply that by? Yep, that's right. Make sense? Right now when I plug in 0, the purple one goes through -16. I want it to go through -64. What do I multiply -16 by to get -64?
4.
Make sense?
That's my best friend.
Again, this is all about problem solving. That's the point. I want you to view it that way. Let's look at number 8.
Yes, thank you. I know how to get
It says, consider these equations. Which equation will match the graph shown? Well, in this form, this tells us our x-intercepts, right? Where it hits the x-axis. This guy would hit the x-axis at what? What would the first one hit the x-axis at?
Question 10. I can't even tell you solve. We're doing question 8.
Is this question 10?
Yeah.
It's number 10. Oh, I hear what you're saying. Slide 10. I'm on slide 10.
Okay.
Slide 10. Slide 10.
Mitchell, what game are you playing?
The number I know.
All right, this equation right here. Gentleman in the back. What would our x-intercepts be for the first one here?
What?
Anybody in the back? Where would we cross the x-axis for these two? -2 and what?
0.
Not 0. -2 comma 0 and and 5 comma 0, right?
Yeah.
So -2 and 5 is where we cross the x-axis. Does this cross at -2 and 5? -2, 5. That makes sense. So that's a pretty good guess, right? Does this open upward or downward?
Upward.
Upward, because there's a positive, right? There's no negative in front. Let's check the vertex. Can we see it? Oh, we can. All right, let's check the others. -2 and 5 here, so where would it cross the x-axis? Jamba, where would we cross the x-axis for this one? 2 and what?
-5.
Yep, so 2 and -5 would be here and here, so that's obviously not it. Jordan, where would we cross the x-axis here? 2 and -5, so that checks out, right? Or actually, 2 would be here and -5 would there, so that doesn't work. Olivia, where would we cross the x-axis here? Yep, so that one could be this, right? 'Cause that's crossing at 5 and crossing at -2. But the vertex would be above it because it's opening downwards, right? So this one can't be it. So this one must be it. So explaining our thinking, we say, well, it's got to be A because it crosses the x-axis. Crosses the x-axis at -2, comma 0, and 5, comma 0, and it opens upward. All right, challenge number 8.
Yes. I have some of it.
Now here's the deal. Parker realized that this can't be the vertex. Because if it was, it would have to be short over here and then long over there. And parabolas open up evenly, right? So that can't be the vertex. Now those are the points I want to cross, right? So if I want to cross at -6 and +2, I'd have to write something like this, right? X, if I want to cross at -6, what do I have to put? +6? So that when I plug in -6, I get 0, right?
And x minus 2.
And x minus 2. All right, so not quite. And that makes sense because this one opens upwards, and we want it definitely to open downwards, right? So what would I do?
Y equals -1, parentheses, x minus 2, parentheses, x minus -6, parentheses.
What did you say?
Do you want me to say it again?
All right, so I've got the negative. What now?
X minus 2.
Okay, so I have my x minus 2 later. That's fine.
And then x minus -6.
X minus -6.
Yes.
Well, x minus a -6 is just x plus 6. So we have the same thing. Okay, right? This is just multiplication, so it doesn't matter what order you do it in. And minus -6 is the same thing as plus 6. Does that make sense to you?
Yep.
Okay. So we have the same thing, but does it go through this point?
No, I just looked this up, so I should know how to get to that point.
So the question is, how do we make that happen,
I
right?
don't know.
We have it opening the right way.
Can't you make it go skinnier? Like make it.
We need to make it skinnier, yeah. Actually, kind of wide, depending on how you look at it, also wider, right? Okay, so here's how we're going to tackle this problem. The vertex, where is it always located, right? Where's it always located? We have two sides going up, right? Where's it always located? The vertex is always where? At the bottom of it, right? Or the top, depending which way we're going. This one, it's going to be at the top, right? What else? Not just at the top, but where? There's plenty of answers you could respond with, so just start taking guesses.
I don't know.
Tell me stuff that's true. I'll tell you whether that's what I'm looking for or not. Okay? Doesn't mean you're wrong. It just means it's not what I'm looking for. Vertex is always going to be right in the middle. Exactly.
Yes.
So if we know we want to go through these 2 points, we need to find out where the middle is. That will get us the x value for our vertex, right? Right? It'll tell us where it is in the x direction, right? So we're at -6 and +2. What's halfway between -6 and +2? All right, I need you guys to stop.
-2.5.
-6 and +2. What's the distance between -6 and +2?
Oh, 8.
8. What's half of 8?
4.
So we need to go 4 to the right. 1, 2, 3, 4. That puts us at -2. So our vertex is going to be -2 something, right? It's going to be -2 something up here. The question is, what does that need to be? Well, if we put a point somewhere on this line, it needs to be higher than this point, right?
Yeah.
So it's going to be bigger than 3. 4, 5, 6, something like that. What do you want to check? Maybe 6?
Yeah.
All right, so we need to write it in vertex form. Remember, vertex form is this. Where h and k are the vertex, right? If we want -2, we plug in -2, and what do we get? X minus -2, what's that? +2, right? Simpler way of writing it. And then plus k. What's k in this case? Let's try that. I'm going to write it down here so we can see our original one. Y equals, we haven't specified an a value, so I'll just leave it blank. X plus 2, or is it minus? Oh, it's plus, okay. Plus 2, quantity squared. To square it, you have to do shift 6 for the caret key, right? And then arrow to make sure we're down below, plus 6. All right, so that's this guy. Notice it does have a vertex here, but it's opening the wrong way. So what do I need to do? Negative to make it open downward. Oh, so close. So 6 doesn't work. What do we need to do? I need to move it up higher, don't I, right? Let's try 7. Okay, it goes through there, but it doesn't go through these guys. Ah, man, if I move it up any higher, it'll move off of that. So I've got an idea of what needs to work here. Parker, what do you have to add?
I got both the answers.
You have both of the answers. All right, does everybody see how I went about trying to troubleshoot that? Let's see what Parker has to offer. Parker, give me one of them.
I got y equals negative 0.25.
Negative 0.25.
Yeah. Open parenthesis x.
Okay, so that's negative a quarter. I'm going to write that like this.
Yeah.
Parentheses x
Plus 6.
plus 6.
Close parenthesis. Open x minus 2.
X minus 2. So we have negative quarter times the quantity of x plus 6 times the quantity of x minus 2. Now check it out. Plus 6 means that we have an intercept at negative 6. That's good. We want that, right? Minus 2 means intercept at plus 2. We want that. So he did negative a quarter. That means it's going to open downward. We want that. Let's see if it works. How did you get that, Parker?
He's messing around with the negative.
All right, so guessing and checking to see what worked, right? And this is absolutely right. That's fine to do that. The question is, how do we get that without having to guess and check all the time, right? Because we're not always going to have Desmos in front of us to be able to guess and check, right? And being able to explain it is a good idea. Here's our vertex at negative 2, 4. Notice if we move 2 to the right, or 2 to the left, we go down 1, right? 2 to the left, down 1. Slope is written as rise over run, right? So we went down 1 over 2. Down 1 over 2. That's a half. From here, if we go down 4, we went over 4. Down 4 over 4. So our slope changes. It's not like a line where the slope's always a change, or always the same, right? For a line, it's like go up 2 over 3, then do it again, and then do it again, and that's the line, right? Notice that the slope changes for the parabola.
It's kind of like steps.
Kind of, yeah.
Okay.
From here, we're moving down over 2, down 1, right? But we also have to go over 4, down 4. You see how that changes?
Yeah.
Over 2, down 1 is 1 over 2, right? And then 4 over 4 is a different fraction, right? They're not the same thing.
Wouldn't that just be 1 then? 4 over 4?
Mm-hmm. Yep, and the other one's a half, right? So it changes, right? So what we want is we want to get this kind of slope here by doing this. This says down 1 over 4. If I go down 1 over 4 for this, down 1 over 4 gets me here. Right?
So we would have to have one of them be a fraction because it's not.
Well, we want it to be a fraction, so we want to make it wider, right? So we knew it had to be a fraction. That's why Parker was guessing and checking, right? So what we want to do is we want to find the basic slope between here. Negative a quarter, another way to think about that, is when we go over 1, we go down a quarter. Over 1, down a quarter.
Oh, I see.
You see what I'm saying?
Yeah, okay.
Does that make sense?
Yeah.
We can think of it as rise over run, or we can say, look, the run is always 1. I'm going to do whatever the fraction says. Over 1, down a quarter. Does that make sense?
Yeah.
So over 1, down a quarter gets me there. Now, when I go over 2, I'm not going down 2 quarters. I'm going down something else, right? And that's because the slope changes over time. But the first slope is over 1, down a quarter. We went over to the right 1 and down a quarter. So our slope is negative a quarter. Let's experiment with this.
We're going to do this tomorrow if we have a lot of time left.
I know we don't.
Wow, this class has gone by.
Yep. So you might even learn something.
Whoa. Crazy.
All right, let's talk about this. Let me get off display capture because I want to get the full screen. All right, so let's talk about our basic parabola.
That didn't work.
No, it's fine. It's just not recording the YouTube.
Oh, okay.
It is, but it's recording a different screen. All right, so our basic parabola is this, right? And we know it opens upwards and has a vertex at 0. Let's plug in some stuff. When we plug in 0, we get 0, no surprise, right? What happens when we plug in 1?
It goes up 1.
Right? 1 squared is 1, right?
Oh, it goes over 1. No, just go up 1.
If we go negative 1 and we plug that in, what do we get?
It goes over 1. So negative 1.
You're thinking of yesterday.
Gentleman in the back, zip it. It's really annoying. I had this guy in college named Stan that would talk the whole time and mumble, and it was super annoying. Don't be that dude. Okay? Shout out to Stan. No one liked him. The professor had to stop in the middle of the lecture and be like, what is this, high school? and I know you guys are high schoolers, you could be a little bit less, just a little bit.
What if standard?
We plug in -1. -1 for x. What's -1 squared? -1 quantity squared. -1 times -1 is
Oh,
1.
1. No, 1. Yeah, it would be 1. Sorry.
What's 2 squared? 4. 1, 2, 4. -2 squared.
4.
What's 3 squared?
9.
9.
-3 squared.
-9.
Nope, +9 is quantity. We're plugging it in when we plug it in, we wrap it in parentheses, right? So here's our parabola. Notice the slope isn't always the same. When we go over 1, we go up 1, right? Here, when we go over 2, we went up 4. When we went over 3, we went up 9. What's the relationship between 1 and 1? 1 squared is 1, right?
Yeah.
What's 2 squared?
4.
So when we go over 2, we go up 4.
Yeah.
What's 3 squared?
9.
So when we go over 3, we go up 9.
Yeah.
The slope in front of this starts out at 1 because that's the same as this. And that's our initial slope. So when we have y equals 1/4 of x squared, our initial slope is when we go over 1, we go up 1/4. Because 1 times 1 is 1, and times 1/4 is 1/4. So this sets our initial slope. It doesn't set the rest of it, right? Because then it starts squaring and getting crazy. But the initial slope is whatever this is for that first move to the right. Yes?
So if you have a slope, you can make it more of a parabola or whatever. What's the slope?
The slope, again, quotation marks, will be the first move to the right, will be up 1/4, if that's what it is. Now, what will the second move to the right be? If I do 2 squared, I get 4 normally, right? But here, if I plug in it, I get 4, right? Times 1/4. What's 1/4 of 4?
1.
So now when I move over 2, I get 1. When I do 3, I get 9/4. See what I'm saying? It's going to make it wider
And wider.
because it has a fraction here. So if you want, you can use that concept. If I go over 1, I go over 1/4. If I go over 2, I go over 1. If I go over 3, I go over 9/4. To figure out what your slope needs to be to make sure it hits that exact point. We're not done. Sit down.
Wait, is the test on decimals on Friday?
Yes. So here, if I go over 1, I go down 1/4. If I go over 2, I go down 1. If I go over 3, I go down 9/4. If I go over 4, I go down. What's 4 squared?
16.
10 times 1/4?
16.
16 times 1/4. What's 1/4 of 16?
4.
4. If I go over 4, I go down 4, right? So I knew I needed to go over 4 and down 4. So if I go over 4, I would expect to go 16 for regular, right? 4 squared is 16. But I want it less than that. So 16 times what gets me 4? 1/4. We'll talk about this more tomorrow. We'll be doing number 8 the rest of the time.
Leave this group chat. Guys, it's kind of drained my phone battery.
All right, here's my thought. People in the back, you're not really working. Parker is, you're working sort of. The rest of you guys, it's on and off at best. The point of groups is so you'll work together and talk about math, and you're not doing that. And so if you're in the back, you're not working individually. Everybody else can work together.
I would work.
Besides me and Parker?
Then you should have no problem working individually because you were working, right?
No, it's not.
Awesome. See you guys later.
Well, I
Pass, yeah.
Can me and Parker stay working together?
Yeah, it's fine.
If I'm allowed to come back in, can I take a nap too?
Yes.
Oh,
So,
yay.
I just have one question to finish on my test because I'm getting 100 hours.
Red.
It says this class and then biology.
Seniors, just a reminder to go to the cafeteria during homework.
Samba, you're better at math than you think.
To select you.
We can make you better at math
It's
if
just
we
harder
work.
for me to understand 'cause coming from Vanderbilt to here.
Oh, sure, yeah, for real. But like, you're actually really good. And I think if we get you up to speed here, like my first semester kids are, you're gonna be really freaking good. So thanks for working, man.
In the seat. I own that seat. Don't let Zach Eats take that seat.
No promises.
No promises. He gets it in freaking math. I should get it.
Make sure it's a small one.
make sure you're quiet while I'm working with people, okay?
I want to buy a random question for like 5 minutes.
That's cool.